Are you ready, kids?
Aye, aye, Captain!
I can't hear you.
Aye, aye, Captain!
Oh!
Oh, hello everyone, and welcome to the day 5. Although we did not post it yesterday because technical problems.
Actually...
I spent the entire day trying to solve a problem that was out of my league.
Okay, I had to have made some kind of a dent by now. Oh, come on! Oh!
So,
I am dead inside.
this being said, let's get right to the next 3 problems for today. hackerRank University has the following grading policy. Every student receives a grade in the inclusive range from 0 to 100. So also 0 and 100 are taken into consideration. Any grade less than 40 is a failing grade. Same is a professor at the university and likes to round each student's grade according to this rule. 2 of them. If the difference between the grade and the next multiple of 5 is less than 3, round grade up to the next multiple of 5. If the value of the grade is less than 38, no rounding occurs, as the result will still be a failing grade. So let's do it. A simple implementation for the solution then. What we do, we just do an iteration to the grades and we check the second condition of SAMS is that if the grade is less than 38, obviously it's a failing grade. In that case, we just continue by checking the list of grades. Otherwise, if it's 38 or bigger, we use the find next multiple of 5 method to find the next multiple of 5 grade that it's closest to the current grade. In that case, we use this private method, and what we do in this method is just we take the grade, we check if the grade is divisible by 5. In that case, that grade remains. Otherwise, we just increase by 1 until we get to a number bigger than the initial one that is divisible with 5, and then we just found what we were looking for. After that, we just do another check to see if the difference between the next multiple and the grade is not bigger than 3. If it's less than 3, then we modify the grade in the list with the next multiple. Otherwise, we leave the grade as it is, and in the end we just return the grades back, the same list that was provided. Sam again. I believe it's another Sam. Sam's house has an apple tree and an orange tree that yield an abundance of fruit. Using the information given below, determine the number of apples and oranges that land on the Sam's house. Let's use this beautiful image to explain what actually we need to do. We have the area from S to T that represents the Sam's house, and then A and B are 2 fixed points where the trees are planted, and depending on wind and other factors, apples and oranges fall from some distance of their tree, and some of them get in the red zone, which is Sam's house area, and we need just to, by doing some simple math, find out which of the fruits get in this area. So this is the solution. This time again we create a private method, number of fruits in the area, and for this method we need the list of distances for each fruit, the tree location, the start area and the end area for the zone that we want to calculate the number of fruits that have fallen in. And in this method we take a counter, the count of fruits in area. Initially it's 0 obviously, and then we just do an iteration to the list of the distance value for each fruit. And what we do, we check is the distance of the fruit plus the tree location. It's bigger or equal with the start area, and also if it's smaller or equal with the end area. That means it's inside the area, so we count that fruit as being in the area. So we do the same thing for each of the distances in the fruits list, and after that we just call this function for apples and oranges, and we just then display the results. For the third and the last problem of today, you are choreographing a circus show with various animals. For an act, you are given 2 kangaroos on a number line where jump positive. The first kangaroo starts at location x1 and moves at a rate of v1 meters per jump. The second kangaroo starts at location x2 and moves at a rate of v2 meters per jump. You have to figure out a way to get both kangaroos at the same location at the same time as part of the show. If it is possible, return yes. Otherwise, return no. Good, let's just do it. Again, we create a method to solve this, and what actually we do in the kangaroo function, we just check if it passes. If it passes, in that case, we return no, because it means that for some reason they did not at the same time got at the same distance, and otherwise we return yes. And how we check if they pass, what we do actually is just we check the, let's say for the v1 and v2, the velocities of each kangaroo. If the first kangaroo velocity is smaller than the second kangaroo velocity, we return 4. Why? Because previously in the indication was mentioned in the constraints that all the time the first kangaroo starting point is smaller than the starting point of the second kangaroo. So obviously the velocity of the first kangaroo needs to be always bigger. But if the velocity respect condition v1 bigger than v2, in that case we have a value for is right big. We store it because x1 it's always smaller than x2 in the beginning, and as long as this is true, we do a loop. We increase the position of each kangaroo by their velocity. After each increase, we check if the position it's equal for them. In that case, we return true and we complete it. Otherwise, we check again if the distance of the first kangaroo is smaller than the second kangaroo, and in that case, store the response true or false in the is right big. In case we passed, like the first kangaroo passes the second kangaroo, in that case, it's not possible for them to get at the same position at the same time, and we return false. With this being said, see you tomorrow.